Namaste everyone, welcome. Let us discuss exercise 13.1. First problem is a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is open at the top. Ignoring the thickness of plastic sheet, determine the area of the sheet required for making the box. And second, the cost of sheet for it. If the sheet measures 1 meter square, cost rupees 20. The cost of 1 meter square is rupees 20. This is 1 meter square. This 2 will be somewhere here. It is like that. Okay. So here from the given information, we understand that this is a cuboidal shape in which if you see length is 1.5 meter, breadth is 1.25 meter and height is 65 centimeter. Now this 65 centimeter you can write as 0.65 meter. Either you convert all the dimensions in centimeter or in meter. Whenever we are doing calculation, all the dimensions should be in the same unit. Clear? Yeah. Now area of the sheet required. Now from the given information, top is open. So I will say that area of sheet required is equals to, we have lateral surface area which is 2 times L plus B into H plus area at the base which is L into B. So this is how you can calculate. Now this is equals to, I will put the values, 2 times length plus breadth is 1.5 plus 1.25 into height is 0.65 plus area at the base is 1.5 into 1.25. So this is 2 into, now if we add, you will get 1 plus 1, 2, 0.5 plus 2, 7, 5, 2.75 multiplied by 0.65 plus here 1.5 into 1.25. Now if I multiply this 2 with 2.75, 2 5s are 10, I will get 0. 2 7s are 14, 1 15, I will get 5. 2 to the 4 1 5, so I will get 5.50, that is 5.5 multiplied by 0.65 plus here, now 1.5 into 1.25. So if I multiply 15 by 125, 15 5 are 75, so I will write 5, 7 carry, 15 to the 30, so it will become 37, 3 carry, 15 1 is 15 plus 3, 18, so I will write 18. Now here after decimal we have 1 digit and here after decimal I have 2 digit. So in my product after decimal there should be 2 plus 1, 3 digits. So I will say that this is 1.875. Here it is 5.50, that means 5.5. Now I have to multiply this 5.5 with 0.65. So you can do some rough calculation. 0.65 you have to multiply by 5.5. So by ignoring decimal, 5 5s are 25, 5 6 are 30, 30 plus 2, 32. With this 5 also, I will get 325. Now this 5 plus 2, this is 7, this is 3 plus 2, 5, and this is 3. After decimal, here I have 2 digit, here I have 1 digit. So in my answer, after decimal, I should have 3 digit. So here I will write this as 3.575 plus 1.875. Now 5 plus 5, I have 0. Here after decimal I have 3 digit, here also 3 digit, so I will add 5 plus 5, 10, 7 plus 7, 14, 1 15, 1 carry, 8 plus 5, 13 plus 1, 14. 1 carry, 3 plus 2, 5. So 5.450. This much meter square will be the area. So unit better you write at last when you calculate, when you do complete calculations. So this is area of the sheet required. Now cost of sheet. So for 1 meter square, cost is rupees 20. That is considered as rate. So I will say that cost of 1 meter square is rupees 20. Therefore, total cost, I have total area 5.45. So total cost is equals to 5.45 multiplied by 20. This will give you, now 2 5s are 10, 2 4s are 8, 2 5s are 2 4s are 2 5s are 10, 2 4s are 8. 1 I will add 9 and 2 5s are again 10. And this 0 is there, so I have 1 0 here. And after decimal I have 2 digits, so I will put decimal here. So this is total cost. So my total cost is rupees 109. Now 5.45. So approximately if you take 5 and 20, so it is 100. So I am getting more than 100. That is okay. So means sometimes students do mistakes where to put the decimal. So like this they can calculate the approximate values and then they see their answer whether it is near to that or not. So 109 rupees is the correct answer. So this is how we are going to solve the problems of surface area and volumes. Now your first exercise is only related with surface areas. So we will discuss surface areas only. The length, breadth and the height of the room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the wall of the room and the ceiling at the rate of rupees, this is rupees, so this is rupees 7.5 per meter square. Okay, whitewashing means we are using calcium oxide. Okay, that is chuna, what you say in Hindi. You put that on your walls. Okay, to look brighter. That is whitewashing. Okay, so basically you are doing color to your walls. You are painting. Okay, so solution. The problem is almost similar to the previous one. Only here length is 5 meter, breadth is 4 meter, height is 3 meter. Find the cost of whitewashing the walls of the room and the ceiling at the rate. So we have to whitewash all the 4 walls and ceiling. So therefore first I will find area of all walls plus area of ceiling is equals to area of 4 wall, it will be 2 into L plus B into H, and area of ceiling will be L into B. So this I will get 2 into L plus B, 5 plus 4 into height is 3 plus L into B, length is 5, B is 4, 5 into 4. So here I will get 5 plus 4, 9, 9 into 2, 18, 18 into 3, 54. So I will get 54 plus 5 for the 20. So 54 plus 20, it is 74. So 74 meter square is the total area. And for 1 meter square, the cost is 7.5. So cost, I will say cost for 1 meter square is rupees 7.5. Therefore, total cost is equals to 74 into 7.5. So here in rough, I will multiply 74 by 7.5. So 5 for the 20. 2, 5 7 the 35, 35 plus 2, 37, 7 4 the 28, 2, 7 7 the 49, 49 plus 2, 51, 0, 5, 5, 5. So this is 5, 5, 5.0 because after decimal I have one digit. So I will write 555 only. So the total cost is rupees 555. Okay. Now see the third question. The floor of rectangular hall has a perimeter 250 meters. If the cost of painting of the four wall at a rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. Area of the four wall is lateral surface area. This is the hint they have given. We already know. So in solution, now if you see, they have given total cost. Okay, rate is rupees 10 and total cost is rupees 15,000. So here rate, I will say rate is rupees 10 per meter square. Cost, total cost is rupees 15,000. Perimeter is 250 meter. This is given and what we have to find? Height. Height is question mark. Now from total cost and rate, I can find out total surface area, total lateral surface area. Okay. So here our cost is equals to rate, total cost is equals to rate into lateral surface area. In the previous problem, we are using this formula only to find the total cost. Total cost is rate into lateral surface area. So therefore, lateral surface area will become cost upon rate. Now I have total cost 15,000 and the rate is rupees 10. So I will divide 15,000 by 10. I will get 1,500. So 1,500 is lateral surface area. Now I got lateral surface area. The lateral surface area formula for lateral surface area is lateral surface area is 2 into L plus B into H. This 2 into L plus B is perimeter. So this is perimeter into height. This is lateral surface area. Now lateral surface area is 1,500. So this 1,500 is equals to perimeter, which we know the perimeter is given 250. So it is 250 into height h. So therefore from here I will get height h is equals to 1,500 divided by 250. So this 0 0 cancels. 5 3 are 15, so 30 upon 5 5 the and 5 6 are 30. So 6 meter. Everything is in meters. So the height is 6 meters. So therefore I will say therefore required height of room or required height is equals to 6 meter. Simple question. Fourth one. The paint in certain container is sufficient to paint an area equal to 9.375 meter square. How many bricks of dimension 22.5 centimeter, 10 centimeter into 7.5 centimeter can be painted out of the container? So this is actual, we can say that total area is given. In solution, we say that total area total area is 9.375 meter square. Now, as the dimension of brick is in centimeters, I will convert this total area in centimeter square. Now, why I am considering this as total area? Because I am going to apply the paint on all bricks, and this will cover 9.375 meter square. So I will say that the total area of all bricks is 9.375 meter square. Now 1 meter is 100 centimeter. So here I will multiply this 9.375 by 100 into 100, because here it is meter square, 1 meter into 1 meter. So this will give me 93750. Okay, this is total surface area. It is in centimeter square. Now, for brick, we have length. For brick, length is 22.5, breadth 10. Obviously, all the units are in centimeter, and height is 7.5 centimeter. So, therefore, volume of brick, volume of one brick, I will say, will be 22.5 into 10 into 7.5. I am not going to multiply them because maybe most of the terms will cancel. This is volume of one brick. Now total volume is number of brick into volume of one brick, or I will say that number of bricks is equals to number of bricks is equals to total volume divided by volume of one brick. Not volume, actually surface area of one brick. Number of brick, here it is not. Oh, I am doing something wrong. Why I am finding volume? I have to find surface area of the brick. Okay, not the volume of the brick, because we are painting on the surface area. So here, surface area of brick. Surface area of one brick. So surface area of one brick is 2 into LB plus BH plus LH. This is the formula. Is equals to 2 into length is 22.5 into breadth is 10 plus 10 into height is 7.5 plus 22.5 into 7.5 length into height. Okay, now I have to calculate 22.5 into 10. I will get 225 plus here I will get 75. Okay, these two products are simple. Now 22.5 into 7.5, you have to do some rough calculation. 22.5 into 7.5. So 5 5 is the 25, 2, 5 to the 10 plus 2, 12, 1, 5 to the 10 plus 1, 11. Then 7 5 is the 35, 3 carry, 7 to the 14, 14 plus 3, 17, 1 carry, 7 to the 14 plus 1, 15. So here I will get 5, here 7, here 8, here 6, here 1. Now after decimal, here I have 1 digit, here I have 1 digit. So after decimal I have 2 digits. So here the result will be 168.75. So this is equals to 2 into, now after decimal 75, so I will write that 75. Then this 8, this 5 plus 5, 10, 10 plus 8, 18. Then 1 carry, 2 plus 1, 3, 7 plus 3, 10, 10 plus 6, 16, again 1 carry. This 2 plus 1, 3, 3 plus 1, 4, 468.75. Now with 2 when I multiply, 2 5 is 10, 2 7 is 14, 1 15, 2 8 is 16, 1 17, 1 carry, 2 6 is 12 plus 1 13, 1 carry, 2 4 is 8 plus 1 9. 937.5 is the surface area of one brick. This is centimeter square. Okay. Now number of bricks required is, or number of bricks, simply I will say number of bricks is equals to total area divided by area of one brick. Area of one brick. Now total area is 93750. 93750 divided by 937.5. The zero after decimal, if we have this zeros at the end, then it does not have any significance, so we can avoid to write that. Now sometimes you will find it difficult to divide by decimal numbers, so better you can multiply and divide by 10, so that denominator will become a integer number. In numerator you will get 937,500 and denominator is 9375. Now numerator is 9375 into 100 and this is 9375. 9375 will cancel and your result will be 100. So therefore number of bricks will be 100. So here the paint, how many bricks of dimension this can be painted. So therefore I will say that 100 bricks can be painted. 100 bricks can be painted. Okay, so surface area, here I have to find surface area. By mistake I am taking volume. Now next problem, fifth problem. A cubical box has each edge 10 cm and another cuboidal box is 12.5 cm long, 10 cm wide and 8 cm height. Okay, so I have one cubical box and one cuboidal box. Which box has greater lateral surface area and by how much? And which box has a smaller total surface area and by how much? Okay, so here I will take first for square. For square I have given side length. Let us denote this with A. I have given side length 10 cm. Okay, this is for square, so therefore its lateral surface area if you remember, the formula is for A square, that is 4 into 10 square, that is 4 into 100, that is 400. Now the unit will be centimeter square. 400 centimeter square. This is the lateral surface area. Second, I have to find total surface area also. So total surface area, this I am finding for cube. Total surface area is 6L square, 6A square here. 6A square is equals to 6 into 100 square is equals to 600 centimeter square. Okay, so lateral surface area and total surface area I have find out. This is one equation, this is second equation. Now I will take for cuboid. Now for cuboid, length, breadth and height. Let us see what they have given length, breadth and height. So 12.5, 10 and 8. 12.5, 10 and 8. Unit is centimeter. So first lateral surface area is equals to 2 into L plus B into H. So this gives you 2 into 12.5 plus 10 into 8. This will be 2 into, this is 22.5 into 8. This is 22 to the 44, 45, 45 into 8. So 45 into 8 8 5 the 40, 4, 8 4 the 32, 32 plus 4, 36. So lateral surface area is 360 centimeter square. This is for cuboid. And total surface area, now for total surface area, we will say that this is 2 into L plus B into H plus 2 into LB. Okay, as I already have find out the value of 2 into L plus B into H, I will modify the formula like this, so that I will use this total surface area is lateral surface area plus area of top and bottom. So this is 360 plus length into breadth. Length is 12.5 into 10. 12.5 into 10. Now 2 times, so into 2. So this is 360 plus this is 125 into 2. So 360 plus 250 is equals to 0. 6 plus 5 11. 3 plus 3 6. So 610. This is 610 centimeter square. Okay, this we can consider third, this we can consider fourth. Now the problem is which box has greater lateral surface area and by how much. So here we are getting lateral surface area is 400, here we are getting 360. So 400 is greater than 360, therefore I will say that lateral surface area of cube. Okay, 400 is for cube of cube is greater than lateral surface area of cuboid by, now 400 minus 360 is what, by 40 centimeter square. Okay, and 610, and here we are getting 600. As 600 is less than 610, we will say that total surface area of cube is smaller. Which box has smaller total surface area and by how much? So therefore cube has smaller, therefore cube has smaller total surface area, smaller total surface area by, now smaller by 10 centimeter square. I will say that smaller by 10 centimeter square. Done. This is fifth problem. Let us see the sixth question. A small indoor greenhouse is made entirely of glass pans held together with tapes. It is 30 centimeter long, 25 centimeter wide and 25 centimeter high. What is the area of the glass and how much of tape is needed for all the 12 edges? So a small indoor greenhouse is made entirely of glass, means all the 6 sides there or 6 faces they are made up of the glass. Now its a length, breadth and height is given. So in solution we will see L is given, length is 30 centimeter, breadth is 25 centimeter and height is also 25 centimeter. So first I have to find area of the glass. So area of glass, I have to find total area. So it is 2 times LB plus VH plus LH. This is equals to 2 times length is 30, breadth is 25 plus breadth is 25, height is 25 plus length is 30 and height is 25. So this is equals to, now I can take 25 common. So 2 into 25, 25 let us take common. So inside I have 30 plus 25 plus 30. So 2 into 25 is 50 into, now here 30 plus 30 is 60 plus 25 85. So now the calculation is easy. 0 I will write here because this is 50. Now 5 5 is 25, 2, 5 is 40 and this I will get 42. So 4200 centimeter square is the total area of the glass. So therefore I will say therefore total area of glass is equals to 4250 centimeter square. Now I need to find the length of tape needed for all 12 edges. So 12 edges, out of 12 edges, 4 edges are along the length, 4 edges are along the breadth and 4 edges are along the height. Means there 4 edges are of the length 30 centimeter, 4 are of the length 25 centimeter and 4 are of the length 25 centimeters. So I will say that the length of tape required, how much tape is needed. So I will say length of tape needed, length of tape. Okay, you can take any matchbox in front of you and you can check all the 12 edges and their lengths. So 4 edges will be of length equal to length of the cuboid, 4 edges will be of length equal to breadth of the cuboid and 4 edges will be of length equal to height of the cuboid. So length of tape needed will be equals to 4 times, here I have length plus breadth plus height. So I will get 4 times length is 30, breadth is 25, height is 25. So I will get 4 into, now 25 plus 25 50, 50 plus 30 is 80. 4 into 80, 32. So 320 centimeter will be the length of tape needed. Next question, Shanti Sweet Stall was placing an order for making cardboard boxes for packing their sweets. Two sides of the box were required, the bigger of dimension 25, 25 and the smaller of the dimension 15, 12 and 5. For all the overlaps, 5% of the total surface area is required extra. If the cost of cardboard is rupees 4 for 1000 centimeters square, find the cost of cardboard required for supplying 250 boxes of each kind. So, first I will find the total surface area for one box, okay, for small and big. Then I will find total surface area by multiplying it with 250. Whatever volume I will get, I will multiply it by 5% as the 5% of the total surface area is required extra. Then I have total area of the cardboard and then the rate is rupees 4 for 1000 centimeters square. So using that rate, I will find out the total cost. So here let us start. The problem is lengthy. So for, I will say for a smaller, first two sizes of box, the bigger, first bigger is given. So let us write for bigger box we have dimension 15, 12 and 5. So for bigger box, length is 15 centimeter, breadth is 12 centimeter and height is 5 centimeter for bigger box. And for a smaller box, this is given, right? A smaller box, length is 15 centimeter, breadth is 12 centimeter, and height is 5 centimeter. Rate is given, or I will say number of boxes is 250 of each type. Now overlap is given. Overlap, it is 5%. And rate is given. Rate is rupees 4 per 1000 centimeter square. Okay. So here first I will say surface area. Surface area of big box. So surface area of big box is 2 times LB plus BH plus LH. This is the formula. So 2 times 15 into 12 plus 12 into 5 plus 15 into 5. So this will give me 2 into 15 into 12. 15 to the 30. 15 1 the 15 plus 3, 18. So this is 180 plus 12 5 the 60 plus 15 5 the 75. So this is 2 into, now 5, 8 plus 6, 14, 14 plus 7, 21, 1, 2, 2 plus 1, 3. So 315 multiplied by 2 is 630 centimeters square. A surface area of big box. Surface area of a small box. This is 2 into, now length for a small box is 15, 12, 12, 5. Oh, for big and small I have written the same thing. Now for bigger box the dimension is 25, 20 and 5. 25, this is 25, 20 and 5. Okay. So this part actually I have to write this part must be written here. We delete this, and this is the surface area of smaller box. Surface area of larger box is 2 into length is 25 into 20 plus 20 into 5 plus 25 into 5. So this is 2 into 25 into 2, 50. So this is 500. This is 25 20 into 5, 100. And this is 25 into 5, 125. This is 2 into 500, 600, 700, so 725. And we multiply by 2, 2 to 5 the 10, 2 to the 4, 1, 5, and 2 7 the 14. So 1475 centimeters square. Therefore, now for bigger box and smaller box I got the area. Therefore, total area required by 250 boxes. This will be equal to 250 into 1450 plus 630. 1450 plus 630. So this gives me 250 into 0, 5 plus 3, 8, and 6 plus 4, 10, and then 1, 0, something wrong I think we have done. 6 plus 4 10 and 1 plus 1 2. Okay. 250 into 2080. Let us cross check. 0, 5 plus 3 8, 6 plus 4 10 0 and this 2. 2080. This is total area required. Now area for overlap. Area for overlap is 5%. That is 5 upon 100 into 250 into 2080. Okay. This is area of overlap. So therefore total area is this 250 into 2080 plus 5%. So 5 ones are 5, 5 twos are, it is 1 upon 20 into 250 into 2080. Now this 250 into 2080 is common. I will take out, plus here it is 1 upon 20. So this becomes 250 into, now you can see that I am not multiplying at this stage, because when it is not means asked to find total area. What is asked? To find total cost. Find the cost of the cardboard required. So therefore cost for, I know that 1000 centimeter square, the cost is rupees 4. Therefore cost for this 250 into 2080 into 21 upon 20 centimeter square will be equal to 4 upon 1000 multiplied by 250 multiplied by 2080 multiplied by 21 upon 20. Okay. So this 10 I will cancel from here. 10 I will cancel from here. Then 4 ones are 4, 4 5s are, so I will cancel, and 5 ones are 5 5s are 25. Okay. Then we have 5 ones are 5, 5 twos are 10. I will cancel. Then this 2 ones are 2, so this is 104. So finally I have 104 into 21. So have you seen why I haven't why I have not multiplied? Because in calculation most of the things cancelled out. Now 21 4s are 84, so I will write 4. 8, now 21 into 0 is 0, so that 8 I will add with 0, and 21 ones are 21. So 2184 is the cost. So therefore required total cost is rupees 2184. So 2184 is the required total cost. Simple. Okay, so this is our last question. Last or second last question. Okay. Praveen want to make a temporary shelter for her car by making a box-like structure with the tarpaulin that covers all the four sides and the top of the car. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height 2.5 and the base dimension 4 meter into 3 meter? So here I have length 4 meter, breadth 3 meter, height 2.5 meter. Now when I make the shelter, it will cover the four sides, it will cover the top, but at the bottom, okay, no tarpaulin, as it is ground itself, right? So I have how much tarpaulin. So therefore I will say that area of tarpaulin required, area of tarpaulin required will be equal to 2 times L plus B into H plus LB for top. So 2 times this is equals to 2 times L plus B. Now length is 4 plus B is 3 into H is 2.5 plus 4 into 3. This is 2 into 4 plus 3, 7 into 2.5 plus 4 3 is 12. So here 2 into 2.5 is 5, 5 7 is 35. So this is 35 plus 12, it is 47 centimeters square. So area of tarpaulin required is 47 centimeters square. Simple question. Okay. So we will stop here. In the next class, we will see how we will calculate the volume of volume. So we already know how to calculate, but we will see different problems related with volume of cuboid and cube. Thank you.